When we look upon the universe, we see many great mysteries and wonders. In our solar system, out beyond the Earth, are planets and moons, spheres similar to our world and yet terribly different. They do not welcome life as our world does. Past our solar system in the Milky Way, new suns flare into life and ancient stars die. Further out in the immense reaches of space, great galaxies swirl rapidly around what may be black holes. And at the farthest reaches of our vision are vast cosmic structures.
The wonder that is the universe probably will never be fully understood by humankind. Indeed, it is unlikely that our most basic question will ever be answered. Where did it all come from? To know that, said the poet, is to know the mind of God. But even if the ultimate question cannot be answered, there are still plenty of lesser questions to keep us occupied. In most cases, the distances to be traveled to unlock the secrets of the universe are very great. I say most cases because there is a frontier ripe for our exploration that we have just barely begun to understand. It is the universe next door, the planet Earth.
The Earth itself, like most of the solar system, is about 4.5 billion years old, formed from the swirling cloud that created the sun and all its satellites, and then pelted continuously by meteors. The young Earth took shape. The sphere heated up and became completely molten. The heavy iron sank to the core, and the surface became a shifting sea of hot lava. There were no features to speak of, no oceans, no polar ice caps, no mountains or valleys. The crust had yet to take its solid form, but the makings were there. For millions of years, the churning cauldrons of volcanic activity spewed out water, not the liquid we know today, but a superheated steam that came bursting out of the lava with tremendous violence. As the planet began to cool, the steam cooled too, and its molecules clumped together. Eventually, they formed droplets too massive for the atmosphere to support, and they fell back to the surface. These were the first rains of planet Earth. Volcanic activity went on unabated for many hundreds of millions of years, releasing more and more steam into the atmosphere, and the rain fell continuously from the sky. Then, the first small puddles appeared on rain-cooled ground. These pools flowed together as streams that formed lakes, and then eventually Earth's great oceans. Beneath an exterior of apparent calm, volcanic forces slowly reshaped the surface from below. Moving magma thrust great crustal slabs into the air, and mountains appeared upon the Earth. Under the new ocean's floor, jets of lava burst through the crust and grew until islands appeared. Wind, rain, and tides wore away these mountains and islands, but others took their place. It is a process that continues today. About 1.5 billion years after the planet first formed, something extraordinary happened in shallow reaches of water. In the warm brew of Earth's young sea, waters spiced perhaps with the methane and ammonia of meteorites and sparked by the lightning that raged across the sky, chemicals called amino acids took shape.
When these amino acids came together, they began to form proteins, chemicals which could make copies of themselves from the raw materials of compounds floating near them. This was the dawn of life on planet Earth.
The warm sea where life emerged likely covered 75% or more of the globe and provided a fertile womb for creatures who reproduced into billions upon billions of individuals. First, simple blue-green algae appeared. They were individual cells floating in the nourishing water. It would be another 500 million years before these creatures began to organize. The cooperation of many individuals proved immensely successful. These became stromatolite colonies. They flourished and filled the many shallow areas of the seas with their biscuit-like communal structures. Later, as millions of years of evolution took place, some animals who took oxygen from the water developed the ability to extract it from the atmosphere as well. The first animals to walk on land were amphibians, but they discovered that plants were there ahead of them.
For a while, these amphibians seemed to be the creatures of choice, the ones best suited for life on the lands of Earth. But then, 225 million years ago, a change occurred, which marked the beginning of the era of huge reptiles which came to dominate both the land and the water. We have given a name to these reptilian monsters. They're called dinosaurs.
We'll return to the Practical Guide to the Universe on the Learning Channel.
Connections to Sunday at 8 on the Learning Channel. I found on the Learning Channel.
We now return to the Practical Guide to the Universe on the Learning Channel. The dinosaurs ruled the Earth for a period of about 160 million years, but some 65 million years ago, nearly all of them became extinct. We suspect that a huge asteroid may have struck the Earth at that time, wreaking havoc on the entire ecosystem. The dinosaurs, unsuited to the drastically changed climate, died out, making way for the rise of mammals.
3,100,000,000 years after the first life was created, creatures that would evolve into the most fearsome animal of all made their appearance in the dense growth of the African jungle. These were the ancestors of man.
The dizzying ascent of man had a decisive impact on all other life on planet Earth. Unlike any species that had gone before, humans began collecting and classifying information about the world around them so that they might alter it to fit their needs. Humans are the only life forms on the planet that have created and used science to explore their world and to understand it better. Through observation and trial and error, humans learned what plants grew well, what animals could be tamed, what made good building materials, and what plants provided relief from pain and illness.
Practical science such as this enabled mankind to create complex societies, complete with grand cities and states. This in turn allowed certain members of the society to turn their thoughts to other less practical studies of the Earth and the heavens around them. Questions were raised and scientifically tested as to why the Earth worked the way it did, what forces were driving it, and most importantly, where it came from. This is a study that continues today. So, what have we learned over the last 5,000 years about our planet? What understandings have we reached? And most importantly, what have we yet to learn?
The Earth orbits its modest star, the Sun, at a distance of about 93 million miles. It tilts on its axis at 24.4 degrees. This tilt changes subtly over time, which may contribute to the ice ages that our planet undergoes every 10,000 years or so. Our modest atmosphere extends about 250 miles above the surface. It contains 78% nitrogen, a little over 20% oxygen, a little carbon dioxide, and traces of numerous other gases. This atmosphere is unlike anything else in the solar system in that it is both the product and the parent of life as we know it. The gaseous envelope of the Earth is a place of continuous change. This dynamic atmosphere interacts intimately with another unique feature of our planet, the oceans. Water and air, these two very different fluids, shape and form each other into complex patterns of movement and exchanges of heat, moisture, and motion. The atmospheric flux we call weather has its counterpart in the Earth's dynamic oceans. Powered by the sun's energy, twisted by the planet's rotation and the gravitational tug of the moon, immense currents connect all the oceans of the globe in one great liquid system. Heat from the sun causes this water to evaporate and drift into the air. As this water vapor reaches ever higher altitudes, it begins to cool and condense. Droplets